Okay, so today we're going to learn another way to solve linear systems. Previously, we solved using substitution, where we would get one variable by itself and then plug the expression that that variable is equal to. We'd plug that into the other equation and then solve. But today we're going to learn a new way. So the steps are, the concept is we're going to add or subtract the equations together to eliminate one of the variables. So sometimes, like at the beginning, the questions we get are easier. They'll be set up to where all you have to do is add the equations and one of the variables will cancel out. Later on, we're going to have to do more of step one, where we have to multiply one or both of the equations by a constant, which is just a number, so that at least one pair of like terms has opposite coefficients. So we need to just jot these down and then we'll kind of reference them back as we work through the steps, okay? So step one is basically you need to make sure that a variable can cancel out. And so you might need to multiply one or both equations by a number. Step two is to add or subtract the equations to eliminate one of the variables. And then three is to solve the resulting equation, which will give you one of the variables. And then step four is to plug that variable back in to one of the original equations to solve for the other variable. So you're still getting the x and the y, the two solutions. So let's take a look at our first example. Now, this example is one of the easy ones that I told you is already set up. Look at, and what you're looking for is, and we'll write these, the easiest way to solve these is to write them in standard form, ax plus by equals c, so that the x's and the y's are lined up vertically. And you notice right here that you have a positive 2y and a negative 2y. And you know that if you add those together, that makes 0. So what you're actually allowed to do is you're allowed to say, all right, I'm going to add these two equations together and get a new equation. So you just add the like terms. 3x plus 3x is 6x. 2y plus negative 2y is 0. So 6x plus 0 is just 6x. And then 4 and negative 4 is 0. And now I have an equation that just has x that I can solve. So I just divide both sides by 6. 0 divided by anything is 0. So I know my x value of my solution is 0. And now I need to find the y value. To find the y value, all I have to do is plug the solution I got, the variable I solved for, I just have to plug that into one of the other equations. So I'll just take equation 1. And I'll plug a 0 in for x. Anytime I substitute in for a variable, I always replace the variable with empty parentheses and then put whatever is inside there. That's a good habit to start because that'll help you keep track of negative signs later on. Well, 3 times 0 is just 0. 0 plus 2y is just 2y. And then so we get 2y equals 4, and then we divide both sides by 2, and we get y equals 2. So that means that our solution is the ordered pair 0, 2. So there, what we did, our strategy was we noticed that we had variables that had opposite coefficients. That's what we're looking for. Variables, no, I wanted highlighter. Variables that have opposite coefficients. Y had a positive 2 in this equation. Y had a negative 2 in that equation. So when we added these equations together, the y's canceled out. So that is what we're looking for. We're looking for a variable that has opposite coefficients in the different equations. I am looking for a pen that will let me write without thinking I'm trying to do weird things. Okay. Now, take a look at this equation. Look at the variables. I'll line up my x. I have a -10 for this coefficient, a -5 for that coefficient. Look at my y's. I have a -6 for this coefficient and a +3 for that coefficient. So here are my options. If I wanted to make x, if I wanted to cancel out x, if I wanted to cancel out x, I would multiply the bottom equation by a number that would make the coefficient of x the opposite of that one. So if I multiplied by -2, that would give me, for equation, for if I did 2 times -2 times equation 2, that would give me -2 times 5x would be positive 10x. -2 times -6y would be positive 12y. And then -2 times 23 would be -46. So if I wanted to cancel x, I would multiply equation 2 by -2, and then I could add it to equation 1. So that's how I could cancel x, or I could choose to cancel y. And I'm just going to show you both. You don't do both. I just want to show you that you need to look at the different options and see which one that you think might be easier. And so I'm doing kind of like a slower method of showing you how to do that right now, which eventually you'll be able to kind of do in your head. If I wanted to cancel y, I could multiply the top equation, equation 1. If I multiplied by 2, that would give me a 6y up here and a -6y down there. So if I was going to cancel, or if I was going to try to cancel out the y's, I would multiply equation 1 by 2. That would give me 2 times -10x, that's -20x. 2 times 3y, that's positive 6y. And then 2 times 1 is 2. And then I would just write equation 2 under it. -5x minus 6y equals 23. So this is kind of a process that, so now I have to say, which one of these would I rather solve? And to me, it's probably this one, because the numbers are a little bit smaller, maybe. The 6y minus 6y, where I would have the minus 10x, and 10x would cancel over here, and I would have 15y. Although it really doesn't matter. Either one of them would, I think, take the same amount of steps to solve. But the thing that I want to point out here is that at the beginning, before we got any of this stuff, at the beginning, we had to look at our equation, our system of equations, and decide which variable we wanted to cancel out, because we would only go one of these directions. And so the way I think about it is I will generally say, what would I have to multiply by, and which one would leave me with smaller numbers? And so I would look here and be like, all right, if I was to multiply by 2, then I would have a positive 6 up top. So this is probably the way that I would go. I would just say, all right, I'm going to multiply that by 2 so that I get a positive 6y right here. And then you have to remember, when you're multiplying the equation, you have to basically distribute to everything on both sides of the equal sign on this stuff. Okay, so we will just not use this. I'm just going to solve this one right here. So I'm going to add these two equations together. So negative 20x and negative 5x makes negative 25x. Positive 6y plus negative 6y is 0. 2 plus 23 is 25. So then we can divide by negative 25. Negative 25 divided by negative 25 is 1. 1x. 1 times x is just x. 25 divided by negative 25 is negative 1. Once we get our first variable solved for, I know the x value of our solution is negative 1. Now I can plug that x back into any one of my equations. I think I'll plug it into this equation 2. So I'll take equation 2 over here, negative 5. I'm going to be plugging in for x, so I'll just put my empty parentheses right now in place of the x. Minus 6y equals 23. And then what was I substituting in place of x? Well, x is negative 1, so I'm going to put a negative 1 inside the parentheses there. So now negative 5 times negative 1 is positive 5. To get the 5 off away from the 6, this is really, you can think of this as being 5 minus 6y, but you can also think about it, 5 minus 6y is the same thing as negative 6y plus 5. And if we write it that way, it might be easier to see that we really need to subtract 5 from both sides to get that off of there. So I'm going to subtract 5 from each side of the equation. So then we get negative 6y equals 23 minus 5 is 18. Then to get y by itself, we divide by negative 6. And so we get y equals negative 3. All right, and then we've got a real life problems, modeling with math. So a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. That's a lot of vans. Oh, that's too dark. Why do they make a highlighter so dark? Ooh, wanted to make it a different color. B receives 2 large vans, 3 small vans, for a total cost of $160,000. What's the cost of each type of van? So you always know what your variables are going to be by looking at the question. What is the cost of each type of van? You solve for your variables, right? So my variables, what is the cost? So I'm going to pick a variable to be the cost of a large van. I don't like using L because it looks like a 1. So I'm going to do B for big and S for small. So B equals cost of big van and S will be the cost of small van. Okay, so then we need to come up with some equations. Yeah. There are, let's see. So let's do by location maybe. Like we got an equation for each location. There's 5, location A has 5 large vans and 2 small vans, and it costs $235,000. So we can make an equation from that. So for location A, 5 large vans, right? So that, how much would that cost? That would be 5 times B, 5 times the cost of a big van. I am writing letters. So the cost of all their vans would be 5 large vans, so 5 times the cost of big van, plus how many small vans? 2. 2 times the cost of small van, and that equals 235,000. I'm just going to write 235, and then remember to add 3 zeros at the end of my answer later on. Equation or location B, they had 2 large vans, so 2 big vans plus 3 small vans, and their price was $160,000. Okay, so now we've got our 2 equations here that we can solve. And let's see, we might have to, looks like we're going to have to multiply both equations by something, right? Because think about this. If I was going to try to cancel out B, what do I multiply times 2 to get 5? We don't want to start introducing like decimals and fractions and stuff. We need to have whole numbers. So what we have to do is we have to say, if I wanted to get rid of B, what's a number that 5 and 2 both go into? Well, they both go into 10. So if I wanted to get rid of B, one way I could do it would be to multiply the top by 2, because that would give me 10B, and multiply the bottom by -5, because that would give me -10B. That's one option. If I wanted to cancel out B, that's what I would do. Multiply the top by 2, because that would give me +10B. Multiply the bottom by -5, because that would give me -10B. But let's see if it might be easier to try to cancel out the S's. If I wanted to cancel out the S's, let's see, the 2 and 3 both go into 6. So if I multiplied the top by 3, that would give me a 6S. If I multiplied the bottom by -2, that would give me -6S. And I think I would rather multiply by smaller numbers. So I'm going to pick that. I'm going to cancel out S by multiplying the top equation by 3, because that'll give me a +6S here. And multiplying the bottom equation by -2 to get a -6S right there. Okay, so I am going to go ahead and start figuring out my new equations. 3 times 5b. 3 times 5 is 15. So that's going to be 15b. 3 times 2s, that's going to be plus 6s equals 3 times 235. That's going to be my calculator friend helping me. Three times 235. 705. And now for the bottom equation. Negative 2 times 2b, that's negative 4b. Negative 2 times 3s, that's negative 6s. And negative 2 times 160 will be negative 320. Two times 160. Yeah, 320. Okay, so then what I need to do is now if I add these equations, the 6s and the negative 6s will cancel out. So while I have my calculator open still, I'm going to do 705 minus 320. $385. So this is 385. 6s minus 6s is 0. 15b minus 4b is 11b. So 11b equals 385. Cross our fingers that 11 goes into 385. 385. We're going to divide both sides by 11. Woohoo! 35. So we're going to divide both sides by 11, and we get b equals 35. So the cost of a big van is $35,000. And then to find the cost of a small van, we can plug a 35 in for B on any one of our equations. So I'll take equation 2 because it has smaller numbers. 2 times B plus 3 times S equals 160. So I was just using equation B over here. And I'm plugging a 35 in for B. So 2 times 35 is 70. Subtract 70 from both sides. Then we get 3s equals 90. Divide by 3, and we get s equals 30. So that means the price of small van was $30,000. All right, here's some extra practice problems that we can do after the video. Let me go ahead and stop the recording.